Mathematics have been around for as long as humans roamed the earth. It surrounds our everyday life, even in places we wouldn't expect.
Through mathematics, people have developed civilizations, understood the universe and where we fit, and even simply found ways to amuse themselves.
We owe even our most complex inventions, such as computer programming, to early developments in math. Fractals are a mathematical discovery that have been put to use to power complex computer systems.
Through mathematics, people have developed civilizations, understood the universe and where we fit, and even simply found ways to amuse themselves.
Fractals can be found in computer systems, or even at the root of our religion. This is the case in Africa, where a mathematician named Ron Eglash discovered Africans using a simple system of binary in their religion, thought to be where modern binary was conceived.
Math helps build structures to provide shelters. Architects use math to create beautiful 3D shapes at unimaginable sizes. Tensegrity was coined by Buckminster Fuller, who used math to create shapes that define what anyone thought was possible. Complicated math lies behind finding the exact formula to balance compression and tension.
Mathematical thought encompasses basic principles in the world as well as complex and sometimes impossible ideas to perceive. Here at the University of Arkansas in Mathematical Thought 2033, students are given the opportunity to reach out and connect to the math world they normally wouldn't have access to. Math 2033 promotes mathematical literacy and inspires non-math thinking people to create works in the world of mathematical creations, and allows them to expand their minds to infinity and beyond.
Hello, I'm Brianna Patterson.
And I'm Zach Wilson, and we're here to bring you a recap of the Math 2033 fall semester works.
The class has been buzzing with activities, and we're here to show you some of the math projects created by regular students inspired by Dr. Woodland and Dr. Harris.
If you would have to explain what Math 2033 is to someone that has no idea, never heard about it, how would you explain it to them?
It's basically mathematics for those who've always hated mathematics. And the goal of the course is to show the passion that we have about the subject and why we think it's really interesting. And the ideas in mathematics are not just about how we do arithmetic or those rules you have to learn in algebra, but there's a lot more to mathematics, and you can get that culture and get those ideas and look at it in the same way that you learn Shakespeare in English, and you can go out and see a Shakespeare play, or you can read the books yourself or see the influence of those books and other things you're reading. We don't get to see that for mathematics, and nobody teaches that. So the idea is to get that idea of mathematics being deeper into the culture, into people's, persuade people of that, and also tell them a bit more about what the mathematics that's helping, especially drive things on the internet, communication, what that mathematics is, how it works, and basically the importance and beauty of mathematics.
This first group took on the tedious task of creating a scale model of the famous Mayan temple. Let's take a closer look.
Today I will be meeting with the Mayan Project's group leader Charlie Withnell and mathematical expert Jordan Lambert to discuss some specifics of construction and math involved in the reconstruction of the infamous Mayan pyramid of Chichen Itza.
How did you decide on the Mayan pyramid as your project?
The Mayans are well known for their use of math in the construction of their temples and other monumental architecture that's common to the Yucatan Peninsula in Mexico. And the El Castillo Chichen Itza is a perfect example of their use of astronomical bodies and other very primitive ways of building structures very precisely, because they didn't have access to the wheel or any of calculators, obviously, and rulers, and just it's pretty amazing how they built such a monumental structure with such limited technology and resources. So I thought it'd be a good example to demonstrate that how people of the past could use math to build such a great structure and with very limited resources.
What materials were used in the construction of the model?
Each layer of the pyramid was constructed out of sheets of styrofoam insulation and sealed together with silicone. After it got constructed, it is painted with craft paint, with each side getting its staircase and the temple complex on top.
After dabbling in Mayan mathematics here, what do you think is going to happen in 2012?
Well, it's rather interesting controversy, but I don't know, probably nothing.
Your thoughts haven't been influenced by your construction of the Mayan pyramid?
No,
the accuracy of their mathematics?
I mean, they were pretty good for their time, but I just don't know about predicting the future, so I'm not quite sure about that one.
All right. Well, thank you very much for coming by, and good luck with everything else.
Thank you.
Hi, I'm Lindsay Strong. This group you're about to see did various experiments in the style of Mythbusters. They delved into math by looking at things, especially Newton's temperature formula.
Hello, I'm Dan Byers. Chainmail has been used for centuries as a protective material to be worn during battle. Did you also know it can be used as material to build mathematical structures? Led by Josh Soldate, this group of students explore the versatility of these ancient rings and how to build a 3D structure out of solid metal.
And welcome back. I'm Michael Moore. Have you ever looked at an optical illusion? You're staring directly at a mathematician's creation to fool you. These eye tricks have been around for years, and that's what caught the attention of this group, who decided to raise the walls of a very tricky house.
Hi, I'm Flannery Watson. This next group decided to build a mathematical structure called the hexayard. This building is used in many countries as quick relief, and it can be constructed with limited time, knowledge, and material. Let's see what Dr. Harris has to say about it.
I'm Edmund Harris, a maths professor at the University of Arkansas, and this is a hexayard. And it's a very simple structure. So you first take 6 boards of plywood that are 8 foot long and 4 foot high. You can get those from your standard plywood supplier, wherever you get your plywood. And you form them into a hexagon. So this base is a hexagon. And when you've done that, you take another 6 sheets, the same size, and you cut them in half on the diagonal here. And when you do that, you can screw 2 of them together to make a larger triangle. And that triangle can fit together, 6 of them can fit together to make a hexagonal based pyramid. That hexagonal based pyramid you can lift up and put down on top of your hexagonal walls. And that creates a small house. It's 8 foot high in the middle, 4 foot high at the sides. You can put beds around the sides if you to use that space, or just as storage if you're more than 4 foot high, which most of us are. And it's very easy to build. This one was built by a team with some experience of building but not special training, led by a mathematician, and if that doesn't prove it's easy to build, I don't think anything would.
Throughout the semester, we've not only learned about mathematical theories, but about how that math ties into our everyday lives.
Math 2033 helps expand the view of math to people who wouldn't normally take a closer look. The liberal setting allows creation and free flow of learning.
Too bad the semester's over, Zach.
I know, Brianna.
For now, we say goodbye, but remember to keep on exploring.
And remember, don't panic.
It's Math 2033, sometimes called thought. It's Math 2033, you never learned so much about math. It's Math 2033, sometimes called thought. It's Math 2033, you never learned so much about math. Dr. Harris taught us about Nash and how to put things in code. Don't know how I use it yet, but it feels good to know. Dr. Woodland taught us to color and how to count. It sounds like kindergarten, I know. It's nowhere close, 'cause it's Math 2033, sometimes called thought. It's Math 2033, you never learned so much about math.